Hello again, physics students. This is Mrs. Buchanan, and this is video lesson number 4, and we will be covering learning objective number 5. This is Newton's first law of motion as we continue our discussion of his law of inertia. Let's revisit our big idea: forces cause changes in motion. And again, we will be describing the relationship between mass and inertia. Kick an empty can, and it moves. Kick a can filled with sand, and it doesn't move as much. Kick a can filled with steel nails, and you'll hurt your foot. The nail-filled can has more inertia than the sand-filled can, which in turn has more inertia than the empty can. The amount of inertia an object has depends on its mass, which is roughly the amount of material present in an object. The more mass an object has, the greater its inertia, and the more force it takes to change its state of motion. Mass is a measure of the inertia of an object. Mass is not volume. Don't confuse mass and volume. They're entirely different concepts. Volume is a measure of space and is measured in units such as cubic centimeters, cubic meters, and liters. Mass is measured in the fundamental unit of kilograms. If an object has a large mass, it may or may not have a large volume. For example, equal-sized bags of cotton and nails may have equal volumes, but very different, unequal masses. How many kilograms of matter an object contains and how much space the object occupies are two completely different things. Which has more mass, a feather pillow or a common automobile battery? Clearly, an automobile battery is more difficult to set in motion. This is evidence of the battery's greater inertia and hence its greater mass. The pillow may be bigger and it may have a larger volume, but it has less mass. Mass is certainly different from volume. Mass is not weight. Mass is often confused with weight. We say a heavy object contains a lot of matter. We often determine the amount of matter in an object by measuring its gravitational attraction to Earth. However, mass is more fundamental than weight. Mass is a measure of the amount of material in an object and depends only on the number of and kind of atoms that compose it. Weight, on the other hand, is a measure of the gravitational force acting on the object. Weight depends on the object's location. So mass is a property within the body, and weight is an outside force on the body. Mass is inertia. The amount of material in a particular stone is the same whether the stone is located on Earth, on the Moon, or in outer space. Hence, the stone's mass is the same in all of these locations. This could be demonstrated by shaking the stone back and forth in these three locations. The same force will be required to shake the stone with the same rhythm whether the stone was on Earth, on the Moon, or in a force-free region of outer space. The stone's inertia, or its mass, is solely a property of the stone and not its weight. But the weight of the stone would be very different on Earth and on Moon and still be different in outer space. On the surface of the Moon, the stone would have only 1/6 the weight it has on Earth. This is because the force of gravity on the Moon is only 1/6 as strong as it is on Earth. If the stone were in a gravity-free region of space, its weight would be 0. Its mass, on the other hand, would not be 0 because mass is different from weight. So we can define mass and weight as follows in this chart. Mass is a quantity of matter in an object. More specifically, mass is a measure of the inertia or laziness that an object exhibits in response to any effort made to start it, stop it, or otherwise change its state of motion. Weight, on the other hand, is the force of gravity on an object. While weight and mass are not the same, they are proportional to each other in a given in a given place. Objects with great mass have great weight. Objects with little mass have little weight. In the same location, twice the mass weighs twice as much. Mass and weight are proportional to each other, but they are not equal to each other. Remember that mass has to do with the amount of matter in an object, while weight has to do with how strongly that matter is attracted by gravity. 1 kilogram weighs 10 newtons. In the United States, it's common to describe the amount of matter in an object by its gravitational pull to Earth, that is, by its weight. In the United States, the traditional unit of weight is the pound. In most parts of the world, however, the measure of matter is commonly expressed in units of mass. The International System of Units, or SI, unit of mass is the kilogram. Its symbol is small k, small g. At the Earth's surface, a 1 kilogram bag of nails has a weight of 2.2 pounds. The SI unit of force is the Newton, obviously named for Isaac Newton. 1 Newton is equal to slightly less than a quarter pound, about the weight of a quarter-pound burger after it's cooked. The SI symbol for Newton is large N, capital N, and is written with a capital letter because it is named after the person Isaac Newton. A 1 kilogram bag of nails weighs 10 newtons in SI units. Away from Earth's surface, where the force of gravity is less, the bag of nails weighs less. If you know the mass of something in kilograms and you want its weight in newtons at Earth's surface, multiply the number of kilograms by 10. Or if you know the weight in newtons, divide by 10 and you'll have the mass in kilograms. Once again, weight and mass are proportional to each other. This ends this lesson. Thank you.